Alright, this is the week 7 problem set explanations. Problem number 1 is telling us about a specific manufacturer that wants to make light bulbs that last for 700 hours. Some burn out faster than others, letting F be the fraction of the company's light bulbs that burn out before T hours, so F of T always lies between 0 and 1. I make a rough sketch, meaning that most of the light bulbs will last 700 hours, but some will not, and some will always last for longer than 700 hours. So they'll go towards that one upper bound, but never reach it fully. And the meaning of our RT equals the F prime of T is that the F prime of T is obviously the derivative of our F of T function, so that if art of T equals F prime of T, that would most likely mean that the rate in which our light bulbs burn out before T hours, would most likely be the rate in which the light bulbs burn out before T hours. That is what this derivative is explaining to us. And I find the value of the integral from infinity to 0 of RT dt. So from here we can write the limit as t approaching infinity and replace our r of t to f prime of t over t to 0. So f prime of t dt, which equals the limit of t as t reaching infinity, f of t from t to 0 as our bounds. So that gives us the limit of t approaching infinity, f of t minus f of 0, f of t being 1, f of 0 being 0, 1 minus 0 is 1. And explanation for that means that this 1 number is meaning that 100% of our light bulbs will stop working after some time, meaning that no light bulbs will last forever. Alright, moving on to question number 2. It's giving us a table below of a leak. We're supposed to use the trapezoid rule to find the amount of water leaked, estimate that. So I set up our trapezoid equation by 1/2 of our first function plus all of our other functions squared plus 1/2 of our last function squared, all that times dx. Our dx is 6 minus 0 divided by 6, or just 1. Plugging all those numbers in as given on our data table, I get 14.76375 liters spilled over 6 hours. And moving on to our last problem, we were given a simple graph, and we were told to estimate the dots for n equals 12 months, obviously. So I found that each month I estimated where that dot was on the graph. So like month 0 was, or our very first dot was -5 degrees Celsius. Our first month was -4, then -5, then 3, then 10, then 17, then 23, then 24, then 23, then 19, 11, then 4, then -4. That's all in degrees Celsius. And we set up the trapezoid rule, or sorry, not the trapezoid rule, the Simpson's rule, which is S of 12 being our n equals our first number, x0, not being multiplied by anything, then a repeating method of multiplying by 4 and 2, and 4 and 2, 4 and 2, 4 and 2 until I reach our 12th number, which is then just not multiplied by anything. So by plugging in all those numbers, I get 300, and then that's all multiplied by delta x divided by 3. So plugging in all the numbers I had for my data table, I got 367, and then 1/3 of that was 122.33. And then to find out the average temperature per month, I just divide that number by 12, which gave us an average temperature of 10.19444 degrees Celsius.